All right, so we're going to move on to section 2.4. This is all about linear functions. So linear function is a function of the form f of x equals ax plus b. This is a linear function. Some of you all may note this is the same form as f of x equals mx plus b. And basically, if you plot these linear functions, their graphs will be lines. So we're going to basically go through and just the initial part of this section is graphing stuff, then we'll do slopes, talk a little more about graphing, and then we'll finish up talking about something called average rate of change. So they give us a function for our first example. They give us f of x equals 2x plus 6, and they want us to graph it. They want us to give domain and range. We know that this is a line because it's the ax plus b form. This is a diagonal line, so we know that automatically, since this is a diagonal line, let me kind of, and I know it's diagonal because I have a slope that is, I have a number like m times x here, so that tells me it's a diagonal line. So this means the domain and range are both negative infinity to infinity. So anytime you have a diagonal line, domain and range are both negative infinity to infinity. To plot the graph, we're just going to get 2 points and then graph the line based off of that. So I'm going to choose x is 0. If x is 0, 2 times 0 is 0, plus 6 gives me back 6. And then if x is 1, I'm going to use 1 for my second x value. 2 times 1 is 2, 2 plus 6 is 8. So I'll have a point up here at 1, 8. And if I just connect the dots between the 2 points, that will be the graph of my line. And we can see that the line extends forever to the left and forever to the right, so it does hit all real numbers. And for the range, it extends forever downwards and forever upwards, so it hits all y possibilities. So its domain and range are both all real numbers. So next they want us to graph and find the domain and range. So graph, find, we'll just say domain and range. And they give us the function f of x equals -3. And I'm going to kind of combine this with another thing. We'll say part A, find f of x is -3, and part B, do the equation x equals 4. So if you have f of x equals a number like this is going to be a horizontal line. And if you have just x equals a number like that, that's going to be a vertical line. So for part A, when we go to graph it, we have a horizontal line down here at -3. And if we look at it, its domain, so this isn't a diagonal line, so we know that the domain and range both aren't all real numbers. This is horizontal. The domain will be all real numbers because this extends forever in either direction in the x's. But the range, the only y value you're allowed to get back is down here at -3. So the range will only contain the number -3. For part B, when you got a vertical line up here at 4, so we go out to 1, 2, 3, 4. There's a vertical line there. Again, this isn't diagonal, this is vertical, so its domain and range are not both all real numbers. Its domain, the only x value you're allowed to hit here is 4. So its domain is just 4. And its range, it extends forever downwards and forever upwards. So in this case, the range is all real numbers. So you can kind of see if it's a horizontal line, the domain's all real numbers, and the range will be the single y value where the line goes. And if it's vertical, they're flipped. The range is all real numbers, and the domain is the single x value where the line is. So that's graphing domain and or that's graphing horizontal and vertical expressions. Next, they give us an expression like 2x plus 4y equals 1, and they want us to graph this. And they want us to find the domain and range. So this right here, this is actually, this is a standard form of a line. So let's kind of write that down in a different color here. We'll say standard form. Standard form of a line is ax plus by equals c. So if we have a expression in that form, we know it's a diagonal line, or we know it's a line. And given the information that they have here, we know that this line's diagonal. So this is a diagonal line. If it was a vertical line, it would just be x equals a number. If it was a horizontal line, it would be just y equals a number. Since this has both x and y's, it's a diagonal line. So domain and range, those are both all real numbers. Now to graph it, we just need to come up with 2 points, and then we can graph the line based off the 2 points. So I'm going to look at using x equals 0 for my first point. If I put 0 in for x, this term goes away, and the equation becomes 4y equals 1, which says y is 1/4. So I have the ordered pair x value 0, y value 1/4. And then the other way, I'm going to put 0 in for y. This term will be 4 times 0, so it'll be nothing. And the leftovers will be 2x equals 1, which I can divide the 2 across and get x equals 1/2. And so I get 1/2 0 for my second point. So I can plot those 2 points on my graph. X value positive 1/4, y value 0. And then x value positive, or sorry, I did that backwards. X value 0, y value 1/4, which is right here. And then this is x value 1/2, y value 0, which is there. And then we can just kind of connect between them with the diagonal line. And that'll be your graph. Okay, so that is a way, if you have this a standard form equation, you're asked to graph it. That's a way of generating 2 points that you can connect the dots with. And if you don't like these 2 points, you could always choose like x equals 1 and x equals 2 or x equals 5 and then just plug in and solve the equation out. So next we have the slope formula. This should be the same one that y'all have used for a long time. It basically says the slope of a line, if you're given 2 points, you subtract the y values, put them over the x values, and that will be the slope of a line through points x1, y1. So in this case, for this example, they want us to find the slope. And they give us a couple situations. Part A, they give us points -4, 8, and 2, -3. For part B, they give us points 2, 7, and 2, -4. And for part C, they give us points 5, -3, and -2, -3. So for this one, we say, okay, y2 is -3. Minus y1 is 8. All that over x2 is 2. Minus x1 is -4. -3, take away another 8, is -11. 2 minus negative, minus the negative is plus, so this would be 2 plus 4, which is 6. It doesn't really reduce down to anything nicer, so we say, all right, that's -11/6. Here we get y2 is -4. Minus y1 is 7. That's all over x2, which is 2, minus x1, which is also 2. This turns out to be -11/0. Division by 0 is never good, so this is undefined. You got divide by 0, which doesn't work out. The last one, x2 is -3, minus x1, which is also -3. All that over it's y2, which is -3, minus y1, which is also -3. All that over x2, which is -2, minus x1, which is 5. So this is going to be minus the negatives positive. We have -3 plus 3 is 0 over -2 minus 5 is -7. 0 over -7 is just 0. Okay, so that is a couple different cases of using the slope formula. They want us to note a couple things here. Horizontal lines. have slope 0. So actually this part C here would correspond to a horizontal line because it slopes 0. And vertical lines have slope undefined. So this part B here that turned out to be undefined, that represented a vertical line. All right, so next they want us to give us an equation and ask us to find the slope of a line. So for this example, we get 4x plus 3y equals 12. They want us to find the slope. So to do that, we're going to get in form y equals mx plus b, and we'll just identify what's the letter sitting in front of x. So to solve this for y, I'm going to subtract the 4x term across. So I get 3y equals, the positive 4x comes over as negative 4x. We divide everybody by 3, so I get y is negative 4/3 x plus 12 divided by 3 is 4. And then the number that's sitting here, this is y equals mx plus b format. So this number here is sitting in where the m would be. This is the slope, the number sitting in front of x. So two last things that we're going to do here to wrap this section up. If we're given the point x value 1, y value 3, and slope negative 1 over 2, and we want to graph the function, or graph the line, we're just going to talk through how to do that real quick. So step 1 is you plot the point x value 1, y value 3. We plot the point 1, 3. And then we use, for the slope, we use that this is rise over run. So we have a rise of negative 1, which means we go down 1 unit. And we have a run of positive 2, which means we'll go to the right 2 units. And that gets me a second point I'm guaranteed is on my line. Once I have the 2 points that I know are on the line, I can connect between them with a by drawing a line in like that. And then the final thing we're going to look at here for today is average rate of change. So we got average rate of change over the interval a up to b. This will equal f of b minus f of a, all that over b minus a. So we'll just do a quick example to show you all how this works, and then so that's good enough for section 2.4. So we want to find the average rate of change of the expression f of x equals x squared plus x plus 2 over the interval 1 up to 3. So 1 is going to be a, 3 is going to be b. Our average rate of change equation is going to be f of b, which is f of 3, minus f of a, which is f of 1, all that over 3 minus 1. So to get f of 3, I put 3 in for the x's. 3 squared is 9. 9 plus 3 is 12. 12 plus 2 is 14. Minus, I put, to get f of 1, I put 1 in for the x's. 1 squared is 1. Plus 1 is 1. 1 plus 1 is 2. Plus 2 is 4. It's all over 3 minus 1, which is 2. 14 minus 4 is 10 over 2. 10 divided by 2 is 5. And that's our average rate of change. And we'll stop section 2.4 there. That kind of touches on all the things we needed to touch on.